Let's begin with Domain 8. Domain 8 is software development security. It has an average weight of 11%. There are 5 sections in this domain as detailed in the exam outline at ISC2 website. Today I will cover only 8.1, which is about understanding and integrating security in SDLC. The Software Development Life Cycle, SDLC, also known as the software development process, is started to achieve particular information handling objectives of user groups. It goes through iterative stages that adapt to shifting user needs. The actions that make up these logically arranged phases include understanding user requirements, development, and design. The process flow is determined by many approaches like waterfall and prototyping. Regardless of the methodology, it is critical to incorporate security operations into each stage. By determining security requirements before development begins, security experts like CISSP play a key role. To satisfy these demands, resources must be set aside for planning, creating, and testing security features. Additionally, the system lifecycle, SLC, goes beyond creation to include operations, maintenance, decommissioning, and disposal, all of which require consideration of crucial security controls including vulnerability management and media sanitization. SDLC methodologies. We will discuss 3 most popular software development methodologies. 1. Waterfall. 2. Agile. 3. DevSecOps. Before getting into the methodologies of software development, let's take a closer look at System Life Cycle or SLC first. SLC is formed of SDLC plus maintenance and disposal. SDLC is Software Development Life Cycle. The selection of a development methodology by an organization will depend on a variety of variables, including the amount of time available, the organization's tolerance for software faults or errors, and the complexity of the project. The same organization may employ several approaches as well because different groups would have different needs. Though they vary in how each phase is carried out, all techniques generally comprise the same basic phases. It's crucial to consider security as something that is interwoven throughout a complete organization rather than as a distinct entity. With this strategy, security protections may be modified with ease to match evolving software development practices. For instance, testing security controls in a platform like PaaS may fall under the purview of multiple teams within the organization rather than just one development team. This shared approach ensures security is a collective effort, and not just the concern of one team. There are several SDLC models available, each with a different name for the phase it represents, but they all carry out similar actions in roughly the same rational order. There are 3 main steps. But at this point, I should tell you that these steps are not always sharp. They can slide over each other to different extents depending on the methodology. Step 1 is initiation. What do we need? Why do we need it? Do we really? All these questions are answered in this phase. Initiation means the starting point of a project. It's when a business decides they need a new system. They outline why they need it, write down what they need the system to do, and assign resources like money and people to make it happen. Need is identified, and requirements are gathered in this. It's basically the first step in getting a new project off the ground. To sum this up, first of all, need is identified, then management approval is taken, then further analysis is done on the requirements. Once ready to go for design, a further approval from management may be required. Initiation is complete when organization knows what software is about to be developed and why. The business has agreed to go for it. So, a cost-benefit analysis has been done by now. A business case has been submitted and approved. Further cost benefits and approvals may be required later based on the methodology chosen for the development phase. Step 2 is development. Development means building the system according to the plans. Initiation phase has already figured out how the system should work and what it needs to do. Then, they design how it will look and how it will work. After that, they actually create the system, either by writing new code, buying pre-made code, or combining different pieces of code together. Based on the methodology, the steps can slide over, run in parallel. But basically this is the phase where the system starts to take shape and become a reality. The third and the last step of SDLC is deployment and delivery. Deployment means putting the system in a place where it can be used in order to check the function. This involves testing to make sure the system works as it's supposed to, and meets all the requirements. It's like setting up a new app on your phone and making sure it works correctly before you start using it. Such independent testing is often referred to by professionals as V&V, which stands for Independent Verification and Validation. Through verification, we confirm that it has been developed in the right way. Through validation, we confirm that the software does the things it was supposed to do. Sometimes only a small group of users are given to run the software for their feedback on their experience, then more and more users are given to use it. This is called canary release. Canary release is a deployment strategy in which a new version of a software application is released to a small subset of users before being released to all users. Microsoft and Google are examples of organizations who release certain features to a smaller audience first, test the new version, and identify any problems before it is released to a wider audience. Once the software is found reliable, it is ready to be delivered to all the users, and approval from management is taken. This approval is formal and written, and is commonly called accreditation. This ends SDLC part of SLC, which has two more phases. Firstly, operations, maintenance, and improvement. Software has been delivered, it's working. Don't we have to maintain it, and add new features if required? And some changes might be needed because of changing environment. Changes must go through change management processes. As you can see that improvements create new requirements, we are back to step 1, initiation. So, a new cycle of software development can start. Hence, SDLC is called a cycle. So, some models consider improvement as part of the SDLC, while most others consider it as part of the SLC but not SDLC. The minutiae of differences are not so important. Let's focus more on what actions are taken, and why. The second and the last step of SLC is decommissioning and disposal. It is not uncommon to let go old software and make way for the latest. We upgrade systems. Let's say your organization has been running on a legacy ERP software over the last 5 years. You decided to replace it with a completely new ERP on a cloud platform. While disposing the previous, you will have to plan and evaluate the effect of the transition. You will have to take backups, implement change management, get board of owners' approval on the decommissioning. You will have to defensively destroy certain data before getting rid of the software. This breaks the old cycle, but creates a new cycle. And hence the name, System Life Cycle. Waterfall method strictly follows a project plan and schedule. Once development is started, it can waste much resources if stopped. The waterfall method can be a suitable choice for certain types of projects where the requirements are well understood, clear, and unlikely to change significantly throughout the project. Let's take an example. In certain regulated industries, such as healthcare or finance, where there are strict documentation and compliance requirements, waterfall can be beneficial. It allows for thorough documentation and validation processes, ensuring that every stage is well documented and auditable. Waterfall helps to avoid risks from implementation failure or frequent change management. To overcome the drawbacks inherent to the waterfall, some modified versions have been developed. A modified waterfall, sometimes abbreviated MWF, is a tweaked version of waterfall in which it is possible to move back to previous step in case of any issues, reconfirm, and then again move forward. Another modified version of waterfall, which is often confused with MWF, is called sashimi. Sashimi has overlapping phases. It's used when the software is complex and can continue over a long period of time. Unlike MWF, phases overlap in this model, and feedback continues throughout the process. One other popular development method, which is also derived from waterfall, is spiral. This method uses multiple short rounds to deliver and improve the product in each go. This is usually done for projects which have massive impact in case of failure. The process involves an intense use of risk assessment, cost-benefit analysis, and change management. Hence, this adds huge figures to the development cost from overhead cost as well as in terms of development time. After waterfall, we have number 2. Agile development. This is increasingly gaining attention, especially in project management in general. Let's concentrate on it a bit. In Agile, software is initially delivered with fundamental features, followed by iterative development that adds more functions. This approach supports quick small releases, and progress is measured by the functionality achieved from users' point of view. Each make-deliver phase is called a sprint, beginning of which the schedule is reviewed every time after a lesson-learned session is held, feedback for which comes from both the users of the software as well as the developers. Frequent testing helps reduce the chances of defects reaching production environment. Such frequent testing requires automation to avoid errors and to make it fast. Agile methodology uses extreme programming, or XP, which is a fancy name for the use of integrated team with every stakeholder. It enables pair programming where 2 programmers code together, helping each other with their knowledge and oversight. XP also enables code refactoring, which simply means the removal of unneeded, junk codes which professionals call crufts. Agile is a test-driven development, or TDD. In TDD, developers start by creating a test that checks if a specific part of the software works correctly. Then, they write the actual code to make the test pass. If the test fails, they modify the code until it passes the test. The goal is to ensure that all tests pass, indicating that the software functions as intended. Agile principle includes Scrum. Scrum is a framework which enables a lightweight cross-functional team. It centers on a team with diverse skills, including 3 essential members, 1 from each of the 3 groups. A specific time period called a sprint during which crucial tasks are carried out, and several significant project elements called artifacts, such as backlogs and increments. The first member to consider is the Scrum Master. This is the one who removes hindrances and enhances communication between the other members, so, basically a facilitator. This method has several feedback loops, one of which happens on a daily basis, and is called daily Scrum, which are ideally face-to-face stand-up meetings, as dictated by the Agile Manifesto. The manifesto has 12 principles. You can have a look, link below. While certain development approaches are structured around the concept of iteration, assuming that the project will undergo multiple cycles, take the prototype model, for instance, where a basic version of a system or application is created and shared for feedback, and subsequent development stages are then influenced by this feedback, and the refined version is released for further evaluation. Unlike the iterative models, the cleanroom methodology assumes that flaws cannot be fixed once development is complete. It focuses exclusively on defect prevention, targeting zero defect. And last on our list is DevSecOps. Let's first try to understand DevOps before we get into the sec part. Dev is for the development team of the software. Ops is for the IT operations team. An additional team exists in DevOps for quality assurance, called the QA team. The high-speed development could have lost quality if this third team did not exist. In my opinion, this team is crucial. As it is not called DevOps QA, you need to put some extra effort in remembering the QA. DevOps is complementary with Agile software development. Several DevOps aspects came from Agile methodology. It uses all the good stuff in Agile, for example, automated code testing and verification before forwarding to next phase, which is usually the production phase. Traditional or manual testings are avoided as much as possible. DevOps emphasizes people and culture, and seeks to improve collaboration between operations and development teams. DevOps teams typically use a variety of tools and technologies to automate their work and streamline their processes. Here are some examples of DevOps practices. 1. Continuous integration and continuous delivery, or CI/CD in short. CI/CD is a set of practices that automates the software development and delivery process. This allows teams to deliver new features and updates to customers more quickly and reliably via an assembly line approach called pipeline. 2. Infrastructure as code. Infrastructure as code is a practice of managing infrastructure using code. This allows teams to automate the provisioning and configuration of infrastructure, which can help to reduce errors and improve consistency. 3. Microservices. Microservices is an architectural style that breaks down applications into small, independent services. This allows teams to develop and deploy services more quickly and independently. 4. Containerization. Containerization is a technology that allows teams to package applications into containers that can be deployed and run on any platform. This can help to improve portability and scalability of applications. If an organization goes for cost cutting, spending on security comes into their attention as it does not produce anything directly. Organizations can go without security, or they think they can. But are you sure you need no lock in your vault, or encryption for your confidential message? While security is generally considered as non-functional or sometimes non-operational requirements, owing to the increasing importance of security in software development, SEC, which stands for the security aspects, makes its way into it. Importance seems so high that although QA is not in the name, SEC is added in between Dev and Ops to represent the idea of splicing security in, and this gives DevSecOps. Some even consider SEC before DevOps, highlighting that security should be prioritized. DevSecOps has security baked into the process, as opposed to the duct tape method where security is retrofitted later resulting in large expenses. DevSecOps has its own manifesto in their webpage, link below. As a CISSP, you must carefully consider contexts and business needs before making any decision. Your knowledge, experience, and ethics is your guiding compass. This ends our discussion on SDLC and SLC for CISSP.